Welcome everyone. Today's topic for the discussion is Introduction to IMS IP Multimedia Subsystem. In this video, let us explore the fundamentals of IMS, which is an innovative framework for delivering a wide range of multimedia services over IP networks. We will start our discussion by explaining what IMS is, and then we'll look into the requirements from user, interworking and interconnection point of view, ensuring a seamless and efficient deployment. Moving on, we will delve into the diverse range of IMS services that enhance overall communication experience, from voice and video calls to messaging and presence services. We will also get a comprehensive overview of IMS architecture, breaking down its core components and how they work together to deliver these services. Finally, we will address IMS Media Plane Security, discussing the crucial mechanisms in place to protect multimedia content to ensure secure and reliable communication. During Introduction to 3GPP Technologies discussion video, we have seen that 3GPP introduced new core network called IMS, IP Multimedia Subsystem, in addition to already existing circuit switched and packet switched core networks to support various multimedia based applications which are supported entirely on IP based network environment. IMS has been the choice of network implementation regardless of the underlying supported mobile systems, that is UMTS, LTE and 5G, to offer basic telecommunication services such as voice and messaging and supplementary services over the IP based protocols. Today, let us look into what IMS is. IP Multimedia Subsystem is a standardized architectural framework developed by the third generation partnership project, popularly known as 3GPP, for delivering IP based multimedia services. IMS supports the convergence of voice, video, messaging and data services over both fixed and mobile networks, enabling seamless communication and enhanced user experiences. IMS leverages the Session Initiation Protocol SIP for session control, allowing the setup, management and termination of multimedia sessions. IMS architecture is designed to be scalable, flexible and interoperable, ensuring that it can support a wide range of services and adapt to the evolving needs of the telecommunications industry. By providing a standardized and modular approach, IMS facilitates the introduction of new services, improves quality of service and enhances the overall reliability and efficiency of the network. IMS is a critical component for operators looking into deliver high quality next generation multimedia services to their subscribers. Now let us look into various requirements from users and operators point of view. IP multimedia sessions to provide the ability for users to invoke IP multimedia applications to send and receive voice and data communications even when roaming. IMS, complying with the principle of access independence, supports IP multimedia applications via IP multimedia sessions over a multitude of IP connectivity access networks, IP CAN. These include evolved Universal Terrestrial Radio Access Network, that is EUTRAN, which is 4G access network, Universal Terrestrial Radio Access Network, that is UTRAN, which is 3G access network, and GSM Edge Radio Access Network, that is GRAN, which is 2G access network, along with non-3GPP access networks such as wireless LAN, WiMAX, and CDMA 2000, among others. Next one is capability negotiation. IMS shall provide the capability for IP multimedia applications to negotiate their capabilities to identify and select the available media components, quality of service of IP multimedia sessions. Then redirecting of IP multimedia sessions. IMS shall support the capability for the user or the network on behalf of the user to identify an alternative destination for an IP multimedia session or individual media of an IP multimedia session. Then invoking IP multimedia sessions. The user shall be able to invoke one or more IP multimedia sessions. The user shall also be able to activate concurrent IP multimedia applications within each IP multimedia session. Next, handling of incoming session. It shall be possible for the user to either accept, reject, ignore, or redirect an incoming IP multimedia session. As a network option, the IMS shall support a mechanism to enable a different paging policy for voice over EUTRAN versus non-voice over EUTRAN services in LTE access. Next, handling of ongoing session. The user shall be able to negotiate the addition or deletion of media components of IP multimedia applications during an IP multimedia session. It shall be possible for the user to suspend an IP multimedia session and resume that IP multimedia session at a later time. Next, ending a session. The user shall be able to end an IP multimedia session at any time during the session. The network may also end an IP multimedia session at any time during the session, might be due to failure conditions. Prevention of unsolicited communication, meaning handling of spam traffic. IMS should provide means to identify and act on unsolicited communication. IMS should support capabilities that enable IMS to detect that an IMS session is unsolicited and classifying it accordingly. These capabilities should apply to all IMS based services, including real-time as well as non-real-time IMS traffic. IMS should support capabilities that enable a terminating party to report IMS sessions as unsolicited communication. IMS should support capabilities to indicate to a terminating party that an IMS session has been classified as unsolicited communication. IMS should support capabilities to protect a terminating party from IMS sessions that have been classified as unsolicited communication. Next, interworking requirement. The IMS shall support the capability for interoperability with the operator's circuit switch domain, that is 2G and 3G mobile networks, fixed networks such as PSTN, public switch telephone network, internet, and other non-3GPP networks providing IP multimedia sessions. The IMS shall support conveyance of voice calls and multimedia services between IMS users and users in circuit switch domain. Interworking between IMS and PSTN networks shall be supported. The IMS shall support interworking with the internet. Voice interworking with enterprise IP PBX shall be handled. Interworking between IMS based telepresence and other non-3GPP network provided telepresence shall be supported. Next, interconnection requirements include the IP connection used for IMS IP interconnect shall be generic such that it can support all combinations of core network interconnection. The IMS network shall support both bilateral interconnection between two networks and multilateral interconnection provided by intermediate networks. The IMS network shall support both international interconnect and national interconnect. An IMS network shall be able to deliver IMS originating application services and or terminating application services to users that are registered to another network. The IMS network and intermediate networks shall support codec negotiation across one or multiple interconnects to minimize transcoding to provide the highest quality service to the user. Now let us look at some of the key services that are offered by IMS. Starting with multimedia telephony and supplementary services. The IMS multimedia telephony service should allow multimedia conversational communications between two or more users. It provides real-time bidirectional conversational transfer of speech, video, or optionally other types of data. IMS multimedia telephony is a service where speech and speech combined with other media components is the typical usage, but the service is not limited to always include speech. The IMS multimedia telephony service includes supplementary services which are almost identical to supplementary services for circuit switched voice. It is necessary to deploy IMS core network to provide voice services over 4G and 5G mobile systems, as these are designed to be an end-to-end IP based networks which inherently do not support circuit switched voice. IMS is the key enabler to provide voice over LTE and voice over new radio services with enhanced voice quality. Messaging services. These are group of services that allows an IMS user to send and receive messages to other users. IMS messaging services comprise of immediate messaging and session-based messaging. Immediate messaging is a type of IMS messaging service by which the sender expects immediate message delivery in near real-time fashion, while in session-based messaging, the sender expects immediate messages delivery in near real-time fashion. In addition, the sender and the receiver are to join to a messaging session such as chat room before message exchange can take place. Emergency services. The IMS shall support emergency calls. It shall be possible to set up emergency calls initiated by an emergency call number. Telepresence services. Telepresence is a communication system with multiple cameras, microphones, and screens that has the characteristics of gaze direction, eye contact, spatial audio, and scaling images to true size, which in all to achieve the immersive being there experience for participants. Customized alerting and ringing services. These are operator specific services by which an operator enables the subscribers to customize the alerting tone which is played to the calling party and customized ringing tone which is played to the call party. WebRTC, which enables peer-to-peer communication and allows to create rich, high-quality applications for voice calling, video chat, and data sharing without requiring users to install plugins or additional software. Now let us look at the high-level architecture. Starting with mobile device, which holds either USIM or iSIM, and then we have something called IP Connectivity Access Network, IP CAN, which can be 2G or 3G or 4G mobile systems or even latest 5G mobile system. In order to avail IMS services, mobile devices to leverage these mobile systems to establish an IP connectivity towards IMS core network. In IMS core network, we have call session control function CSCF, which establishes, monitors, supports, and releases multimedia sessions and manages the user's service interactions. The CSCF can act as proxy CSCF, serving CSCF, or interrogating CSCF. The proxy CSCF is the first contact point for the mobile device within the IMS core network. The serving CSCF actually handles the session states in the network. The interrogating CSCF is mainly the contact point within an operator's network for all IMS connections destined to a subscriber of that network operator or a roaming subscriber currently located within that network operator's service area. Support of emergency communications require the use of an emergency CSCF. Then we have an application server which hosts and executes the service logic for various IMS services. Then Multimedia Resource Function Controller MRFC in conjunction with Multimedia Resource Function Processor MRFP located in the transport layer provides a set of resources within the core network for supporting services. The MRFC in conjunction with the MRFP provides conference bridges, announcement playback, and media transcoding. BGCF, the breakout gateway control function, which determines the next hop in SIP routing. For fixed network terminations such as PSTN, BGCF selects the network in which PSTN breakout is to occur, and within the network where the breakout is to occur selects the MGCF. MGCF, Media Gateway Control Function, communicates with the call session control function, the BGCF, Breakout Gateway Control Function, and circuit switch networks. The MGCF performs protocol conversion between traditional SS7 ISUP signaling and IP based SIP signaling. IBCF, an interconnection border control function, provides application specific functions at the SIP protocol layer in order to perform interconnection between two operated domains. It enables communication between IPv6 and IPv4 SIP applications. It handles network topology hiding, controlling transport plane functions, screening of SIP signaling information, selecting the appropriate signaling interconnect, and generation of charging data records. Now comes to one other critical aspect, which is media plane security, which includes media integrity protection, which ensures that multimedia content such as voice, video, and data is not tampered with during transmission. This is critical for maintaining the authenticity and reliability of the communication. Media confidentiality protection, which ensures that multimedia content such as voice, video, and data is kept private and secure during transmission, preventing unauthorized access and eavesdropping. IMS uses Secure Real-Time Transport Protocol (SRTP) to protect the integrity and confidentiality of RTP streams. It includes mechanisms for message authentication and encryption, ensuring that the media content cannot be altered or intercepted by unauthorized parties. IMS also uses Secure RTCP, Real-Time Transport Control Protocol, which is used for monitoring and controlling of RTP streams to provide an integrity protection. This ensures that control messages related to RTP streams are also secure and tamper-proof. Next, authentication and authorization, which are critical components to ensure secure access and usage of multimedia services. IMS uses authentication and key agreement mechanism, which is based on a challenge response protocol. This mutual authentication process ensures that both the user and the network verify each other's identities. After successful authentication, IMS performs access control to determine whether the user is authorized to access specific services or resources. This is managed by serving CSCF and other network elements. The user's service profile stored in the HSS home subscriber server contains information about the services and resources the user is entitled to access. The serving CSCF consults this profile to make authorization decisions. Initial filter criteria (IFCs) are used to route requests to appropriate application servers based on predefined rules. These criteria ensures that only authorized services are invoked based on the user's subscription and service entitlements. These mechanisms ensure that IMS not only authenticates users to verify their identities, but also authorizes them to access specific services and resources based on their subscription and policies, maintaining a secure and well-regulated service environment. Thank you so much for your time. I hope you find this information useful and interesting. Please feel free to subscribe if not yet subscribed. Also, in case if you have not yet gone through the previous videos wherein we discussed about GSM, UMTS, LTE and 5G mobile systems, I highly recommend to watch them. Once again, thanks for your time.